So for 12.5, 12.6, you have some boxes to write some vocabulary in. So get these first two written down. If repeats are allowed, use exponents. Just a simple way to speed up the work. So how many 5-letter passwords are possible if repeats are allowed? You know, there's 26 letters, so it's 26 and now on 26, 26, 26, 26, and then 26 to the 5th power. A lot faster to type it into a calculator, use the powers. And again, that's when repeats are allowed. If repeats are not allowed, use factorials. So this one, if you have 6 M&Ms and there's one of each color, or yeah, one of each color. So the very first M&M I choose, I have 6 colors to choose from. Then the next one I have 5 colors. So this one the repeats are not allowed, right? The M&M's gone. You've already eaten it. So it goes 6, 5, 4, 3, 2, 1. That one is factorial, and I will show you how to do that on the calculator. I'm going to show you this quickly. So on the calculator, the factorial, you're going to go into math, slide over to the probability menu, and we'll do some of these NCRs, NPRs, but there's your factorial number 4. So the 6 factorial is what we did. So I'm going to type in 6, math, slide over to probability, number 4, and hit enter. And hit enter. You get that. That's the same as taking 6 times 5 times 4 times 3 times 2 times 1. They're the same thing. If repeats are not allowed and the order matters, use a permutation, it says. So how many ways to assign first, second, and third place to 4 people in a race? So now we're actually, if you finish first, we can tell who finished first, we can tell second, third. So the order matters. This is a permutation, which is like how many ways when we start the race can we get first place? There are 4 people who can win it. Once one person crosses the line, how many ways can we get second? There are 3 people left. Then there are only 2, so it's really 4 times 3 times 2. But mathematically, a quicker way is to do the 4p3, which means the possible number goes here, and this is how many we're using to determine the group. So on the calculator, you do the how many people are in the race, or how many do we have to choose from, 4, math, slide over to probability, grab the NPR, so you have to type down the big number first, then the smaller number second, which is the same as 432. Some of you might be more comfortable doing 432 on the exam. Totally fine, it's the same thing. If repeats are not allowed and order does not matter, use a combination. How many ways to choose 3 ingredients for a pizza from 4 ingredient choices? So what happens is, if you have, I don't know, cheese, pepperoni, sausage, and
pineapple.
Why does it matter? Just write it down.
we'll do sausage, Italian sausage. I don't know. But I'm not putting pineapple on my pizza. Anyway, so what you have to think about in these situations where they're talking about order does not matter, and repeats are not allowed. So in this case, what they're talking about is there are places that put all the other ingredients under the cheese, and then there are places that put the cheese, then all the ingredients on top, right? But it's the same pizza. So if I do cheese, pepperoni, and sausage, and you order sausage, pepperoni, and cheese, we're gonna get the same pizza. The order that they put the toppings on doesn't matter, ultimately. So what they're telling you is if somebody does cheese, pepperoni, and just the regular sausage, and somebody else does the sausage, then the cheese, then the pepperoni, if you do a probability tree, it's like all the probability, the branches in the middle all add up to the same thing. So just 4C3. And again, you go into your calculator, 4, math, probability, do the NCR, then put your 3, and it will spit out there are only 4 different pizzas you can make. It's probably easy for you guys to think about. If I'm making a pizza of 3 toppings and there are 4 to choose from, basically, how many ways can you leave one of the toppings out? Well, I can leave out cheese, I could leave out pepperoni, I could leave out the sausage, and we could leave out the Italian sausage. There's only 4 ways to leave one of the toppings off. Okay? Alright, we have 7 flute players in the ensemble. The names of the 7 flute players are listed in the program in a random order. In how many different ways can we list the names? So the idea is you have 7 people. Because I know their names, if you put my name at the top, my mom will recognize it, right? She wants to see my name first. So 7 people, then 6, then 5, then 4, then 3, then 2, then 1. How many different ways can that happen? You could also type in 7 factorial on your calculator. 5,040. Okay? 5,040 ways that we can list. When you read number 2, notice that it says probability. So it's actually going to be giving the reduced fraction or a decimal. What is the probability that the players will be listed in the alphabetical order? So, how many ways are there to put things in alphabetical order? 1 way. So that's 1 out of 5,040 possible ways. You can write the decimal down if you want, but that's the reduced fraction, so we're good.
Wait, so on the text, what do you use that?
Okay, after the performance, the players are backstage. There's a bench with only room for 4 to sit. How many possible seating arrangements are there? So if they're going to sit down, 4 of them, how many possible seating arrangements are there? Now, depending on how you guys read the problem, right? Some of you might say 7, 6, 5, 4, which implies 7 people do a permutation, put 4 on the bench. That's one way to think of it, right? What do we get over here? Whether you do 7p4 or 7 times 6 times 5 times 4, what do you get?
800.
Is it 840?
Yeah, you.
All right. Some of you might say 7c4. This implies that I don't care where they're sitting, just put any of the 4 people on the bench. So what do you get there? 35? So we have to read the problems carefully and understand, what are they asking us to do. Now they're picking a problem where the 4 people have names, right? Okay? It's flute, so you probably don't, would make an assumption that's probably all girls or something, but Depending on instruments, right, you would never assume that boys and girls, is limited to who can play the instrument. So it could be boys and girls, they're named. So when I look at it, I guess I think in my head that they want us to do it this way. Because they're very specific in this particular problem at the beginning to talk about the names of the 7 people. Right? They're being very specific about the names of those people. So you could make an argument though that it is this one, but I'm gonna say it's this one.
Because it's only be.
So you guys like this one better?
Yeah.
I don't know. I'm agreeing. No. Well, I don't know. I guess the understanding would be like if this were a test question and you were really torn about which one you should do, you could probably explain yourself on the test. We try to, when we write the test questions, avoid those situations where it's questionable. So I agree. This one's a little bit ambiguous about what it's asking. If it's just 4 people sitting on a bench, I certainly would not write the question like this. I would probably say there are seven students in my class, and there are four desks around the teacher desk, and how many different students can come up and ask questions or something. Then you could do it the same way, but I don't know. Let's keep moving. But you guys are starting to understand the difference, and if you're making an argument for 7C4, then you are understanding the difference between combination and permutation. That's what we want. Gina Maria's has 12 toppings. You are ordering a 3-topping pizza. How many different pizzas can you order? So again, we just looked at this very specifically in the vocabulary. We have 12 toppings, and I'm going to be choosing 3 of those at a time. So I either put the P for permutation or the C for combination in the middle. And this one is definitely a combination. Because whether you sprinkle the pepperoni or the sausage first or second, it doesn't really matter. It's the same pizza, right? So what do you get? 12C3? 220. There are 8 girls running in the finals of the 100-meter dash at a track meet. Medals are awarded for 1st, 2nd, and 3rd place. How many different results of the race are there? So we are definitely showing that order matters, because if you get 1st, you get 2nd, you get 3rd, that's a different medal that you're getting. So again, there are 8 people to choose from, and we're only going to use 3 of them at a time, and what goes in the middle? The permutation, which is 336. So 8, 7, 6 is another way to do it. 8 possible people can finish first, then 7, 7, 6. Same as a permutation. What if the same 8 girls are running what they call a prelim? Because if we have too many people in a race, we can't fit them all on the track. So you put together prelims or heats. And so then we're going to run 8 girls at a time, and only the top 2 get to move on. So we might have 4 of these races, and we'll take 2 from the first race, 2 from the second, 2 from the third, and 2 from the fourth. So then we have a finals heat where the top 2 from each race get to run again. So how many pairs of finalists are there? So out of these 8 girls, I'm only selecting 2 this time, but what would we put in the middle? A C. This is a combination. Whether I get first or I get second, it does not matter. I get to go run in the finals race is what they're telling you. Right? First or second gets to move on. So what's AC2 come out as? 28?
Yeah.
Okay. Of the 12 members of the student council, the principal has requested a committee of 3 to study a no cell phones policy for next year. How many different committees could be chosen? So if we have a student council, it's a group, and now I'm gonna select a subgroup out of that 12. So my assumption is everybody knows that it's gonna be 12 and 3. Now, when they form committees, like if they walked into the room right now and took 3 of you out for the committee, doesn't matter if your name is read first, second, or third? No, you're just gonna be a part of the group, you're a part of the committee. It's not committee member number 1 and committee member number 2, it's just, you're in the group. So that's a C. So what's 12C3? 220 again. Alright, Minnesota license plates traditionally have 3 letters followed by 3 digits. How many of these different license plates are possible? So 26, 26, 26. Digits, remember, there are 10 of them, 0 to 9, 10, 10, 10. So on your calculator, you can type in 26 cubed times 10 cubed. What do we get? Are people getting that number?
Yes.
17,576,000? Okay. Now, one of the things you have to watch out for on the test on Wednesday is that the next question talks about probability. So this is some number being divided by the total number of license plate possibilities. So what is the probability that a license plate has no repeated letters or numbers? So when we go to do this problem, first we have to calculate how many license plates have no repeats. So if I choose my first letter, how many letters do we have next? I can only have 25. How many do we have next?
24.
So 26 times 25 times 24 is showing no repeats in the letters. And numbers, 10, 9, 8. So calculate that for me, please.
11,232,000.
232. 11,232,000 license plates that do not repeat. So looking at those two numbers, there's about 6 million license plates if we allow repeats, right? Mm-hmm. So 11,232,000 divided by 17,576. What's the decimal for that? 0.64?
Yeah.
Okay. So about a 64% chance that the license plate number will not repeat. About a 36% chance that you see a repeat. So almost 1 in 3 license plates have some number or letter repeated.